we started to realise that we've got a solution right, we've cracked it.
Now all the team had to do was race to prepare for the design's launch to the British and international press.
It was all hands on deck to get the design right, because we knew what we went out on with then was going to be a picture for the first time in the world's eyes of what London 2012 was going to be.
In November 2007, the day of reckoning finally arrived, and the stadium was revealed to the world.
But this is a purpose-built athletics Olympic stadium.
And the design delivered in spades. In May 2008, Team Stadium kick-started construction. Construction across the Olympic Park depended on concrete. But the ingredients for its production didn't arrive by gas-guzzling lorries. London 2012 had another strategy, which harked back to Britain's great industrial age. The Olympic Park had its own train hub, and London 2012 set a seemingly impossible target: to transport by sustainable means up to 50% of the construction materials to site. Attempting to meet this ambition was a full-time operation for logistics manager Peter Cummings.
We do 8 train loads a day, approximately 1,500 tonnes per train, so that's about 12,000 tonnes of material coming in each day, Monday to Saturday.
Once the materials were unloaded, trucks only had to make a short journey to the on-site concrete factory. Keeping up with demand was a relentless task.
I love pressure. I get a buzz out of doing it. It's not just a matter of just turning up to the office day and going through the usual things that happen. Let's have a challenge. The challenge is the Olympics.
Each train delivered the equivalent volume of material as 75 lorries, which didn't just eliminate traffic chaos, but created a staggering 5 times less CO2 than road transport. The train hub was so effective, entire bridges, as well as other building supplies, were all delivered by rail. Peter's role is one of thousands on the Olympic Park, but he reflects a pride common across the project.
Well, it's being part of something, isn't it? And I think, oh, I handled them tiles, or oh, I handled that bridge, or I was part of that concrete section that built that stadium. So yeah, that's my legacy.
Construction companies had a free choice over transport, and trying to convince them to switch from road to rail wasn't an easy ride. But shifting materials this way was so fast and cost-effective, trains alone beat transport targets, with 57% of supplies rolling in by rail. By November 2008, it wasn't just trains that were on the move. The tunnelling phase to shift the power lines underground had been completed. The pylons could finally be demolished. The Olympic Park site was instantly transformed, and for David Higgins, also set a benchmark.
The tunnelling project was hugely ambitious from the start, and it was the blueprint for the rest of the project. As I used to say to the other projects as they started, well, if the power lines team can do what they did in that environment and set this new level of standard, you can do it too.
A phenomenal workforce, nearly 10,000 at their peak, had to meet David's high expectations. 20% were recruited within the surrounding districts. But high unemployment and a huge skills gap remained a problem. So on the Olympic Park's apprentice scheme, more than 240 people developed their construction skills alongside expert tutors. Apprentices then put their training into action on projects across the park, like Francis Hafner.
The training has changed my life around because, like, before I wasn't doing anything, I didn't have any skills. As a qualified person, I have a better chance of getting a job, so I'm really happy about my future now. Coming from Sierra Leone, I came here year 2000, and it was really hard to sort of catch up. I came from a war basically, so I was a bit traumatized. I didn't know anything, I didn't know who my parents were, and I didn't know what to expect. When I came, I just struggled to basically get my head together. All I want to do is just keep going until I become successful and maybe be an inspiration to other young people that you can come from nothing and become something.
Whilst Francis was mastering how to lay drainage pipes, engineers were on their own learning curve to build the Olympic Park's most daring venue. A structure that pushed everyone involved into unknown territory. In 2012, London will host the world's first sustainable Olympic Games, regenerating over 2 square kilometres of East London, whilst creating an urban park for the future, complete with world-class sporting facilities. The Olympic Park needed an architectural showpiece, a venue to put not just the Games, but Stratford on the map. So for the Aquatic Centre, London 2012 called on an architect who is guaranteed to deliver. Pritzker Prize winner Zaha Hadid.
It was very exciting to be involved in this project because I really believe that the opportunity to really do something, let's say, unusual, but propels people to it.
Zaha's design was extraordinary. A wave-inspired roof captured the flux of water in motion. Inside, a huge open space was created for swimming and diving events. Again, legacy drove design. To accommodate Olympic spectators, 2 temporary stands would lightly connect to the building. But when dismantled, would leave a smaller structure for use after the Games.
It fit very well with that whole idea of landscape and also translation of what a fluid form could be, which fits well with the idea of water and fluidity.
Zaha's Aquatic Centre was so exceptional, it would be located at the park's main entrance, the first venue to be experienced by visitors. But turning her awe-inspiring concept into reality was no mean feat for structural engineer Mike King.
I think when you get a design like this, it's always challenging. You start looking at it as a structural engineer thinking, how are we going to make this stand up, how are we going to make it work?
Mike and his team faced a serious problem. The roof had an area of 11,000 square metres, stretching 160 metres in length and 90 metres wide.
Ordinarily, if you were doing a long span structure of this sort of scale, you have continuous supports along either side.
Lots of columns would ruin the view of spectators. So Mike had to find a different way to support the roof. All 3,000 tons of it.
The eventual solution that we got, it was a combination of that experimentation, trial and error, and also a little bit of dumb luck as well.
Mike developed a radical slimline tripod system. At the southern end, a thin steel reinforced wall would take half the roof's load. At the opposite end, 2 lean, high-strength columns would absorb the remaining forces, channeling them into the foundations.
It's such a dramatic 3-dimensional organic form, but it's only supported on these 3 key areas. So That in itself is quite extraordinary, and it's nothing that I've ever done before.
Over 7 months, huge sections of roof were assembled on the ground and crane lifted onto temporary steel supports. Stuart Fraser was responsible for its construction.
This is in use for, 60, 80 years beyond games. The technical performance of the roof is absolutely critical. This roof's the most complex structure I've had to deliver.
With the roof complete, the specialist supports beneath could be taken down. But to do that, Stuart and his team had to lift all 3,000 tons of steel by 200 centimetres. No one had ever attempted an operation like it before.
That's the make or break time, really, to know that every calculation you've done, every member you've designed is working exactly the way you wanted it to do. And up until that moment, there's always a little bit of nervousness. Is it going to go exactly right?
We were monitoring about 8 different points, literally recording the movement.
After the first lift, I didn't think it had lifted off, which would indicate if it hadn't that there was a problem, so I was quite worried.
Fortunately for the design and the schedule, Stuart had good news for Mike.
Stuart sort of excitedly came down from the upper gallery saying, there's an air gap, we can see that it's lifted off, and that was a fantastic moment for us, but also a great moment of a relief.
We were very pleased to be able to go down and tell Mike that and the roof had ended up within its constraints.
The supports were dismantled from under the elevated roof. Then, all that remained was to lower the gigantic steel roof onto its southern wall. For Mike, knowing the roof was held up by this radical tripod support made up for all the long hours.
It makes all the hard work of the last 3 years worthwhile. The team just worked incredible hours, both on our side and the architects as well. And to see that all come to fruition was just fantastic.
Seeing the aquatic centre leap from concept to reality was momentous for Zaha.
There's always a kind of an element of surprise. No matter how many drawings you do, there's something about the scale of the project on the side which makes it very different.
Well, I think this project has been a classic example of what's so great about London. In many societies, in many cultures, in our industry, everything is regimented, and that doesn't exist in London. There is an environment of people thinking outside of the box. It is a centre where people will say, well, let's see what is possible.
By October 2009, the Olympic Park stadiums were on target for completion ahead of schedule. The basketball arena was emerging fast, one of the largest temporary structures ever built for the Olympic Games. The Olympic Village was also on track to host athletes within a stone's throw of the venues, but to be later converted into 2,800 new residential apartments, with almost half designated as low-cost housing. To the south of the site, a network of 200-year-old canals were playing their part to cut London 2012 CO2 emissions. As with the trains, fossil fuel burning trucks were replaced, this time with specialist barges. Delivering construction materials and removing waste by water was the responsibility of Waterways manager Glenn Buckle.
The 350-ton barges bring in 9 container loads or take away 9 container loads of waste each time. That's equivalent to 9 lorry movements off the road for every single movement.
Shipping materials would not have been possible had it not been for a multi-million-pound dredging programme. Lumps of concrete, rusted cars, and countless shopping trolleys were all dragged from the murky depths. A new lock was installed to manage the water flow, which opened up the waterways to leisure boats in East London and secured access for freight barges to the Olympic Park. But Glenn had faced difficulties in changing everyone's perceptions of green transport.
One of the biggest challenges on the Olympic Park was persuading contractors to use the waterways. That's a cultural change, something that's not very, very easy to do. When you have an industry that's whole supply chain of materials, waste, anything involved in construction is road driven. I don't think we succeeded fully, but we are getting there.
Using the canals for construction was only ever a small part of the regeneration plans.
When I first came to the Olympic Park project, I never thought I would actually be standing here looking at barges and working on waterways. To actually see barges come up this river that hasn't seen activity since the 1950s, that will not only be used for construction, but will also be used for legacy and for the people of the area, I think it's terrific.
November 2009, and the Olympic Park's most permanent sustainable venue was growing at an unmatched pace. The Velodrome will host London 2012 cycling events and combine with a velo park for use by the community post-games. Structural engineer Andrew Weir developed its pioneering design.
What we tried to look for is a highly sustainable design for the velodrome, minimising the amount of materials that to be used and to make sure it could be built quickly and easily as possible.
Andrew and his team could have built the velodrome's roof with heavy steel beams, but devised an eco-alternative.
A cable net roof was an extremely efficient way of spanning over this roof. It uses only a third of the steel that will be used if we use steel beams, and also it allows you to get a very dramatic shape into the roof.
The cable net roof would enable fast-track construction. A job that traditionally might take up to a year, reduced to just weeks.
Very nerve-wracking time. We designed this building for millimetre tolerance, and it really was a time of truth.